Right now, at this very moment, invisible ripples of physical pressure are moving through the air and striking your ear. For centuries, anatomists could trace these physical vibrations moving inside the human head, but then they hit a wall. They simply couldn't locate the exact biological mechanism where that physical movement becomes an electrical impulse. This specific transition point, the conversion of a physical wave into a mental signal, remained the great unsolved boundary of 19th century medicine. That boundary was mapped by an Italian marquis named Alfonso Corti. Born into a wealthy noble family in 1822, Corti abandoned the traditional aristocratic life to travel the scientific capitals of Europe, driven by a deep obsession with human anatomy. He began his medical studies at the University of Pavia, where he spent his days mastering the intricate, highly precise techniques of physical dissection. Corti adopted a strict reductionist strategy. He believed biological processes could be understood by isolating their most granular components, spending years peering through some of the most advanced microscopes of his day. By looking closer than any of his predecessors, Corti was hunting for the exact cellular intersection where the mechanical motion of the outside world becomes a biological signal. To understand what he found, we have to look at the setup. The outer and middle ear act as mechanical transformers. Their entire job is to collect loose sound waves from the air and focus them. When these waves strike the eardrum, they vibrate three tiny bones called the ossicles. This microscopic lever system condenses the energy, taking the initial acoustic signal and amplifying its amplitude until it is 22 times greater than when it first entered the ear. This massive, concentrated force is pushed directly into the cochlea, a tight, snail-shaped structure. The impact generates powerful physical ripples, displacing the fluid trapped inside. Up to this point, the process remains entirely mechanical. It is simply fluid and bone pushing against each other. The actual translation into electricity has not yet occurred. In 1851, Corti published a paper revealing what happens next. Sitting deep inside the cochlea, atop a flexible base called the basilar membrane, he identified a highly specialized strip of tissue. Today, we call this the organ of Corti. It is the primary receptor organ for mammalian hearing. When Corti mapped this structure, he documented distinct, orderly rows of mechanosensory cells. These are now divided into inner and outer hair cells, suspended right in the middle of the cochlear fluid. Projected from the tops of these cells are stereocilia, tiny, finger-like structures arranged in graduated rows. When the fluid in the cochlea ripples from a sound wave, it physically pushes against these microscopic bundles, bending them. This map shows how the ear sorts these incoming vibrations through tonotopic mapping. The base of the cochlea is narrow and stiff, acting as the trigger point for high-frequency sounds, while the apex is wider and much more flexible to capture low frequencies. This brings us to the moment of mechanoelectrical transduction. When a specific frequency displaces the fluid, it bends the corresponding stereocilia by mere atomic dimensions. That tiny physical deflection triggers an electrical action potential that shoots down the acoustic nerve. This is the precise threshold Corti was hunting for. The organ of Corti is the literal site where the kinetic energy of the outside world is translated into the electrical language of the brain. Despite solving one of biology's great mysteries, Corti's scientific career ended abruptly. At just 32 years old, he completely severed his ties with the scientific community and retired to a country estate. He had developed a severe, deforming arthritis. The condition ravaged the joints in his hands, making the delicate work of preparing slides and operating a microscope physically impossible for the rest of his life. Unable to continue his research, he redirected his intellect into his land. He spent his final decades innovating new viticulture techniques, earning profound respect among Italian winegrowers before passing away in 1876. His hands may have failed him, but the incredibly precise map he drew in his 20s remains the absolute bedrock of modern audiology. Corti's work was the height of reductionism. He identified the individual parts to understand exactly how the biological machine operated. Today, biologists recognize hearing as an emergent property, a complex result that no single component could achieve alone. The conscious experience of sound exists only because the air, the mechanical levers, the pressurized fluid, the membranes, and those microscopic hair cells all interact in a flawless, instantaneous sequence. This biological symphony, first mapped by Alfonso Corti, produces the miracle of hearing through the coordinated interaction of every part at once.